that any number from 1 to m can be written as a sum of the various powers of 2, and these powers being the integers. Hence, for example, a number 7 can be written as 2 raised to the power 0 plus 2 raised to the power 1 plus 2 raised to the power 2. If you see all the various other numbers also, say like from 1 to 7 that we have shown here, they can be written as a sum of an integer raised to the power 2 and a sum of all those numbers. These type of this kind of corollary can be very helpful in solving problems like you have to form a number using only these weights or only these numbers. You have to find out in how many ways can a weight be represented using only the powers of 2. The next thing that we are going to cover is powers of 3. Now any number up to 40 can be written as using powers of 3 and doing a subtraction or addition to that number. 14 can be written as minus 3 raised to the power 0 minus 3 to the power 1 minus 3 square plus 3 cube. Hence, this number is being represented by only the number 3 using the signs plus and minus and using various integers as the power of 3. This note is also helpful in case of the similar problems wherein you have to express a large weight or a large number as a sum of the powers of 3. Let's see some of the interesting features of multiples. Now, multiple of 2 will have at the units place either of 0, 2, 4, 6 or 8. For multiple of 4, the last 2 digits of the number will again be divisible by 4. For multiple of 5, last digit is either a 0 or 5. Multiple of 10 has got 0 at the tens place or at the units place, and a multiple of 6, which is a product of 2 and 3, necessarily will be divisible by 3 and will have 0, 2, 4, 6 or 8 at the units place. For multiplying any number by 5, we can simply multiply that by 10 and divide by 2. This will be a lot easier than multiplying that number by 5. Similarly, multiplying by 25 can be done by multiplying by 100 and dividing by 4. So for multiplying any number which can be represented as 5 raised to the power n, you multiply that number by 1 followed by n zeros and divided by 2 raised to the power n. For multiplying by 11, we can multiply the number by 10 and add the number itself to the result. Similarly, for multiplying by 12, we can multiply by 10 and add the double of the number to the result. So basically what we are trying to do is we are trying to break the number by which we need the multiplication into such units that they are easy to multiply and add or subtract. Say for example, for multiplying a number by 18, we can multiply the number by 20 and then subtract a product of that number by 2 from this given number. Hence, this is how you will try to multiply a number by 18 and get the result. Let's see some of the powers or some of the important factors concerning squares. Square of a number ending in 1 will end in 1 and at the tens place will have double of the original number at the tens place. See, have a look at this. You are given a number 1, 2, 3, 4, 5, 1, and if you have to square it, this will have 1 at the units place, and in the original number we have 5 at the tens place. So the new number will have twice the number at the tens place, which is twice of 5, which gives us 10. So we take the 0 and put it at the tens place. Similarly, for 41 square, we put 1 at the units place, we multiply 4 by 2 and we get 8, and we put it at the tens place. These can be easy to understand and they can help you get directly to the result without actually having to multiply the numbers or without having to square the numbers. Any number ending in 1 to 0 will have a square that also ends in the same number as would the square of 120 would end. So if we have to do a square of, say, a large number which ends in 492, we know that this square will have at the units place a square of 2, which is 4. Similarly, a large number which ends at 7 will have at the units place a number 9. Hence, these points can also help you in arriving at the solution just by looking at the options. And in case the options are similar, then you may need to do a little bit of calculation, but at least you can eliminate some options. On next slide, we'll see how you can get to the nth odd number. Now an nth odd number is given as 2n minus 1. So a third odd number is 5. We can get to this number as 2 into n minus 1, which is 2 into 3 minus 1, which is 6 minus 1. Also, for any number n square is the sum of the first n odd numbers. For example, for 4 as n, 4 square, which is 16, is the sum of the first 4 odd numbers. This may sound interesting, but it is something which you will actually be using when you solve such kind of questions in your exam. So to get, the question can be, tell us what is the sum of the first 134 odd numbers, and you know once you square it, that is what the sum will be. Pretty simple, isn't it? Let's see some of the rules which we for fractions. For any fraction n, if n is a numerator and d is a denominator, if the n is same for all, smaller the denominator, higher will be the fraction. If the denominator is same, and in that case higher the n, higher will be the fraction. In case difference between denominator and numerator is positive, if that means that the denominator is greater than the numerator, then fraction with higher value of numerator or denominator will be higher. When denominator is less than numerator, it will be the reverse. And all these points are true when the numerators and denominators are same for all the fractions. Another point is, fraction with the highest numerator and the smallest denominator will be the highest, and vice versa. You need not just mug up these rules. They are logically formed. So if you write down couple of fractions and try to see how these rules apply, you will be easily able to understand what this rule is and how it can help you in solving your problem.